for those who'd like to have it downloaded. I think you're going to find today's talk really good. Gavin Liu from VMware introduced me to Jiangxing about a month or so ago, and I had a call with them a few weeks back. The amount of work that they are doing with EdgeX was really a surprise to me. The types of projects that they're working on are numerous as they are diverse. They have produced their own commercial version of EdgeX that they call EdgeBox. Here to talk about EdgeBox, Jiangxing Intelligence, and all that they are doing with EdgeX today is Dr. Kong Zhang, as I mentioned. He is currently the R&D director of Jiangxing Intelligence. He received his PhD from Simon Fraser University in Canada in 2018. I believe a number of his colleagues at Jiangxing are also from Canada, at least from getting their advanced degrees there. From 2018 to 2019, he was an associate researcher in the School of Computer Science at the University of Science and Technology of China. His research interests include multimedia communications and cloud edge computing. Dr. Zhang, thank you again for presenting for us today, or I guess what in your time is very late, so thank you for joining us. The floor is yours.
Okay, thanks, Jim. I will share my screen and start my presentation. Does it work?
It does. We see it. Thank you.
Okay. Hi, everyone. This is Hong Zhang. Today, I'd like to introduce our products and solutions in industrial scenarios and share how we use EdgeX Foundry to provide the connection between devices and industrial applications. I will follow this outline to introduce our work. First, I'd like to introduce Jiangxing Intelligence. Jiangxing Intelligence is founded by Dr. Jiangchuan Liu. He is chairman and CEO of our company. He is also the professor in Simon Fraser University, the fellow of Canadian Academy of Engineering, and the fellow of IEEE. Dr. Liu's research interest concerns multimedia communications, IoT sensors, cloud computing, and edge computing. Jiangxing Intelligence is founded at Nanjing in February 2018. Later, we received the angel round investment from Sequoia Capital. In October 2018, we established the Research and Development Center at Shenzhen. We choose Shenzhen as the center location because Shenzhen has a good software and hardware development conditions. At the end of this year, we developed AI-based detection algorithms. We also use this algorithm into the products of State Grid Corporation. At the beginning of 2019, we established the marketing office at Beijing. Later, we finished the design and development of Azure cameras and the Azure baseboard. I will introduce these two products later. Then we received the Series A round investment from Green Pan Capital, Sequoia Capital, and Baidu Ventures. At the end of 2019, we finished the design and development of JX IoT Edge platform and our water affairs solution. At the beginning of this year, we own the full stack product and customer services, achieving a good sales channels. Our partners can be classified into three types. The first one is our investors. It contains Sequoia Capital, Green Pan Capital, and Baidu Ventures. They will provide suggestions for our development direction or company direction. The third type is our industrial customers. They give us suggestions for our products and solutions. It contains State Grid, China Southern, Power Grid, Beikong, Water Group, and China Unicom. The third part comes from academia part, such as Simon Fraser University, Tsinghua University, the Hong Kong University of Science and Technology, and other top universities. The professors in these universities will give us the research topic suggestions and other research directions. Next, I will introduce our system. It is called EdgeBox. First, let's review the challenges in edge computing. In industrial scenario, the industrial companies has lots of sensors. These sensors or devices have heterogeneous architectures and operating system. Under the different architectures and operating system, the devices use the different protocols, and the engineer needs the complex development and operations. Another problem in industrial scenarios is because they have different devices and protocols. So for the solutions, we have to achieve different solutions for these services. Another problem is the devices and the sensors in industrial scenarios need the low latency or bandwidth consideration. So currently, the infrastructure in industrial scenario don't support the huge replacement of these devices, but they also want to use some AI-enabled devices. So how to achieve this AI or edge computing upgrade is a big problem for them. As shown in the right part of this slide, we can see according to the huge increase of IoT applications, most of solutions cost will increase according to the superlinear curve. But most of industrial customers cannot accept the huge increase of this part of cost. So our target is how can we reduce the cost when the number of IoT application is increased. We want to make this curve as a sublinear curve. So to address this problem, we want to use a solution to provide a good performance for these heterogeneous devices. So we choose EdgeX Foundry. So why we choose EdgeX Foundry? We summarize three benefits. The first one is EdgeX Foundry provides an ecosystem of interoperable plug and play components. This benefit targets the cloud and edge cooperation. Today, lots of cloud service providers, they provide they achieve or provide the IoT platform to help users manage the edge devices and the application management. But for the startup like us, we want to avoid or reduce the limitation from this cloud service provider. We need a solution to cooperate any public cloud platforms. So we can adopt the EdgeX Foundry and other open source components to build out our own cloud edge cooperation platform. We can achieve a free application management, resource scheduler, and other data management. The second benefit is called is that EdgeX Foundry provide a microservice, loosely coupled software framework. This targets on the application part. For the industrial customers, they need to design their specific applications, such as they want to collect the data and then they want to analyze this data using deep learning or data mining tools. So they need some AI inference applications. They also need to pre-process some high traffic data, such as videos, the continuous camera images. EdgeX Foundry can provide this microservice framework to decouple the applications and the devices data. So for the developers or industrial users, they don't need to care about how to collect this data from these heterogeneous devices. They only need to focus on the development of applications and focus on the data, focus on how to process this data and how to analyze this data. The third benefit is that EdgeX Foundry provide hardware and operating system agnostic. So for this benefit, we think EdgeX Foundry totally match the industrial scenarios because it can it accepts the southbound sensors, controllers, cameras, and many other sensors. For the northbound, it also can provide the containerized applications for the analysis, control, and it also can it is compatible with the public cloud. So it can provide a good abstraction for the devices, for the data control, for the metadata, for the data translation. So based on these benefits, we developed the Azure Box System. So we think Azure Box System is an advanced AIoT edge computing system. I will briefly introduce system from hardware part and software part. For the hardware part, we added two parts. The first one is security chip. It fulfills the encryption part because for some industrial customers, they need to encrypt the video data, and some private data during the transmission and pre-processing. So the second hardware is MCU and FPGA part. It provides the firmware containerization. So this is for the MCU-based low latency control. From the software part, we provide the JXLT Edge platform to provide the northbound service and applications. In the supporting service, we provide AI inference for the AI application distribution, the AI model update. We also provide the data caching QoS. This is for the high traffic data and some small traffic data, but frequently updated. Finally, we also provide the container optimization. This is for the this is for reducing the size of containers. We want to reduce the container transmission time, and we also want to improve the storage efficiency of the containers. So this is the timeline for our industrial AIoT edge applications based on EdgeX. Since from the first version of EdgeX released, we follow this timeline. This is our timeline to develop our applications. We first focus on the edge camera service and the video analysis because this is the urgent requirement. This is the urgent requirement for the power grid scenario. And then when we get the camera service and video analysis service, we provide our own power grid monitoring solution. Then we use this. We transform this solution into the water and fire solution. Based on the experience of these two solutions, we developed our own JXLT Edge platform and Azure Box development kit. At the beginning of this year, we start our research and development works on the energy related devices for the sensing and control device service as a smart substation solution. We also connect our edge devices to Baidu's IoT platform. Recently, we focused on the development of Edge IoT gateway and energy router. So we already have several commercialization in the grid company, power plant, and water fire. Next, I will introduce our products. So our products can be divided into five layers. The first one is IoT platform. As I mentioned before, we developed the JX IoT Edge. This is IoT management platform. It can provide the device performance monitor. It also can provide the container delivery, the image management, and it also provides the data synchronization. So EdgeX IoT Edge can connect to public cloud or on-premise cloud. In industrial scenario, most of customers, they don't like to use public cloud as their solution. They don't like to share their data to the public cloud, and they also want to their data and the smart analysis can be conducted into their private network and private server. So our JX IoT Edge can fulfill their expectation. The second layer is called Edge application. So Edge application can be classified into two parts. The first one is AI application. The second one is industrial edge application. The AI application contains different AI functions such as personal detection, object recognition, and isolation status detection, and garbage classification. We can train the AI model according to the different requirements of these industrial customers. The second part is the industrial edge application. For some users, they need to build a connection between the edge part and the cloud part. So we need to develop the edge, the industrial edge application to fulfill this interaction. But for another user, for a part of users, they need to private deployment for this edge application. So for this user, our application can be deployed on the edge devices without any interaction with cloud. The third layer is called edge middleware. This is EdgeBox. This is EdgeBox in this framework. So using EdgeBox, we can build the connection between cloud edge application and the low layer hardware. So the hardware here, the hardware is called edge base. So we design edge base board. We also use edge board. We also use edge base board into our products. At the end of the left part, I show some products. We can see the left part. The first part is edge cameras. We can deploy edge cameras on the power grid tower. The edge module in this camera can analyze the images and the videos at the edge, and it also can get the alerts of some status information. This information can store into the edge part. It also can transmit to the cloud according to the requirements. The second product is called our mobile camera. It can place into several industrial scenarios to monitor whether the people has a safety height and do they wear a good clothes, a safety clothes in the industrial scenarios. And the other part is called the AI development kit AI chip cluster. This is for the different performance requirements in the water fires or substation scenario. Currently, we are developing the energy facility controller and the ALT gateway. I will next I will use two solutions to illustrate these two types of products. Next, I'd like to introduce some solutions in our work. So the first one is called industrial ALT applications. Here we mainly focus on the electric power industrial. In China, the annual market scale of electric power industrial ALT application is more than 50 billion, more than 50 billion. So according to our current architecture, we can use EdgeBox framework to build a connection between the different devices and the IoT platform. So we can develop the image analysis, grid tower inclination detections, equipment monitoring, traffic statistics, and safety supervision. We can build this AI application with some Edge industrial Edge application on the EdgeBox. And then we can initialize the IoT JX IoT Edge on public or on-premise cloud to support the industrial IoT applications. Using this architecture, we can receive the following technical advantages. For example, we can improve the operation efficiency. We also can achieve 10 milliseconds control latency and reduce the traffic cost because sometimes we only need to transfer the result, for example, the AI result. We don't need to transfer the whole image or the whole video to the cloud. So here we can reduce the traffic cost. Our typical customers include a grid company, water fires, and power plants. We can conduct some safety related jobs or tasks. The second typical solution is called energy facility controller. So here, as shown in the red part, we know the power transformer will transfer the high voltage to low voltage. It also connects different devices. Every devices have a power load. If the loads of every devices reach the peak value, the power transformer cannot countermatch this load. So we also have a schedule strategy in this part, but currently the scheduling strategy can only focus on the country level, city level, or district level. But in today's industrial scenario, we still need some fine-grained scheduling. Take the charging station as an example. The capacity power distribution transformer near the charging station can't match the load requirements of charging pairs, especially in metropolitan. This because the cost is expensive if the power grid company to match the total load of these charging pairs. The second one is every vehicle uses a pile even fully charged. This is low latency. So we want to develop the energy controller with containerized charging scheduler applications. Here we use EdgeX Foundry to collect the information from charging pile and the solar battery energy. So here we can use EdgeX Foundry to collect the charging time, the vehicle type, and other sensoring information from charging piles. We also can collect the data from solar energy station, such as the battery information, the power characteristics. So the energy controller can connect the charging solar power system and power storage system. It can schedule the charging load to balance the load peak. It also can save the power distribution system and save the investment and the user's charging cost. In the charging pile scenario, we can use EdgeX Foundry to build the energy facility controller to monitor the power status and power statistics to analyze or detect the types of devices such as the vehicle types. Another application is called power quality monitoring. Because we can collect this power data in real time, so we can detect the voltage variations, include the interruption, swell, and sag to improve the power monitoring quality and give some alerts to the managers. Next, I'd like to a typical scenario that is how to use EdgeX in the power grid IoT scenario. Based on EdgeX Foundry and EdgeBox framework, we developed the AIoT applications to address the practical challenges in power grid scenario. In this scenario, we are facing the following 5 challenges. The first one is heterogeneous devices. In power grid IoT scenario, we observed that there are 3 types of devices. It is the cameras, the sensors, such as a temperature sensor or smoking detections, and the industrial controllers. So based on the EdgeX Foundry development standard and the SDK standard, we developed the 3 types device services. The first one is MCU and FPGA service. We use this service to abstract the interface with some low latency control needed industrial controller. We want to use this device service to respond the low latency request. The second device service is called image and video service. So we use this service to abstract the camera service. We collect the video streaming and the camera data. So this data mainly are the high traffic data. The third device service is for the sensor module. We use this service to collect the sensoring time series data. This data has a feature is they are the small data, but may be updated frequently. So using these 3 data, 3 device service, we can handle the heterogeneous devices. The second challenge is the industrial AI inference. So here we write our own sharing. We write our own buffer and caching model to save the high traffic big data, especially for the video streaming and the camera. So using this buffer size, we can use our AI inference model to conduct the deep learning model or some data mining model. The third challenge is quick application development, because for some industrial developers, they need a quick application development period. So here we, according to the requirements in the industrial scenario, we observed that we have to need the database to store some key values, because MongoDB has a good writing speed. and it also has a schema-free feature. So we think MongoDB can fit the quick development of these applications. So we use MongoDB as the DB engine. And then because we need to support the different the core among different applications, such as the industrial application and the AI application, because take the power grid IoT scenario as an example, the industrial edge application has to call the AI analysis to process the image and to detect is there any abnormal vehicle around the power. So we introduced RabbitMQ as the implementation of message queue because it needs a small resource consumption, and it also can provide the message persistence. The first challenge is the generic network configuration. This challenge is observed in our practical implementation and deployment, because sometimes in industrial deployment, in industrial scenarios, EdgeBox are usually deployed into some specific network environment, such as 4G, Wi-Fi, internal network or private network. So to reduce the influence of the different networks, we design a network management module to manage the networks of different devices. The fifth challenge is monitor, deploy, and sync tools. This tool targeted to the industrial developers and users. Using these tools, EdgeBox can support different applications to achieve the AI function and to control the devices. It also provides a simple control and data illustration to help user use and manage the different applications and the API gateway. For the future work, we want to illustrate the future work from two parts. The first one is our roadmap. The first future work is we want to develop more convenient development and deploy tools, because most of industrial users they prefer to use C++ or C to develop their applications. But for the EdgeX service development or other application development, the Golang is a good selection because it simplified the configure precise. It also can reduce the size of images The second one is we want to use EdgeX Foundry notification to process our AI notification. Currently, we write our own AI notification service. It uses the HTTP API to provide AI result to the industrial edge application. Next step, we'd like to merge this part into the using the EdgeX core service. The third one is we want to design a new resource management design. This is for we want to provide the API level core statistics. This is for the AI function, because if we want to use our AI to create revenue from the industrial users, we have to we have to calculate how many times this AI function is called. The first one is we want to develop a faster video streaming analysis. So currently, we analyze this video streaming we analyze the video streaming and cameras separately. Next, we hope to process the AI streaming in real time. We want to especially for the AI process. For example, if we detect some abnormal things, we want to show this abnormal thing on the video streaming and show this video stream AI plus video streaming to the users. The fifth one is energy saving strategy. Sometimes our devices are deployed into some bad condition area, bad weather, bad communication network. So how to save the energy? How to save the energy of our devices? Because these devices also use solar power. So if we can't save the energy, maybe the device will die and we can't do anything for them. So we want to use MCU-based energy saving strategy to turn on or off the energy smartly. We also want to get some helps from EdgeX Foundry. The first one is we hope the EdgeX can have a lower performance overhead. Currently, all of writing or reading actions will use the ratings. So these ratings is we think currently for the ARM-based devices, the reading or writing still have a higher overhead. The second one is the device registration optimization. In our device registration, we found sometimes the devices has a unique ID, but sometimes the ID also be changed. We hope the device registration can have a unique ID to make this part smoothly. We also hope the EdgeX Foundry can provide some high availability solutions. For example, if the core data downs, some meta information will be missed and the service cannot work. So we hope if there are some data backup or rotation plan, it will provide some high availability services in the industrial scenario. The first is if current EdgeX UI can be more convenient, it is good for the industrial users and some developers. We suggest if it has a detailed instruction to tell the users how to use the modules, the role engine, step by step, it would be better. The fifth one is according to our experiences, the industrial users want to has a balancing between the AI processing and the service and the industrial edge applications. So if the EdgeX Foundry can be compatible with more frameworks such as NVIDIA's DeepStream, it will help the industrial developers and the users. That's my presentation today. So here we have a Q&A session. my college with me, my college will also will my college Dan Yang will also join this part. He is the EdgeBox project director and the senior specialist. Thank you.
Gong, thanks so much. A great presentation. We really appreciate it. And welcome, Danyang. So we've got a couple of questions that I think have come in from the group, and I also want to open up and allow for questions from the field. Let me get started. You mentioned on your last slide there, Dr. Zhang, that there are quite a few features you had listed, the 5 features that you had listed in terms of what you'd like to see out of EdgeX Foundry. Colin Hutchinson, who is our security work group lead, he asked if you could have EdgeX do one thing better or one feature added, what would that be? So out of those expectations that you listed, is any one of those kind of a priority?
Hi, this is Daniel. I think what we care most today is about lower performance overhead. I think that is the first thing to us. Because actually, you know, in the industrial scenario, the hardware they already have are very a low performance. Like they have ARM chip, and the ARM chip has doesn't have such good performance like Intel chip, especially considering the cost and some power supplies. So I think it is better for us, or even to the EdgeX Foundry, to have the lower performance overhead. So that is the reason we think that is the first priority.
And if I could follow up on that, when you say better performance, are we talking about less use of memory, less use of CPU? Is it truly about power? Because you mentioned that you run on some pretty small platforms. What part of lower performance is important to you?
Basically, the memory is the first pressure, because we are already loaded some artificial intelligence program, and also it will take up lots of memory to do the calculation. So memory will be the first on the first list. A second one is the CPU, but I think that is okay for right now. So maybe memory will be the first priority.
Thanks, Einstein. Another question, kind of a follow-up to that, Henry Lau asks, how powerful does the EdgeX gateway need to be from a CPU, memory, and storage perspective? So the platforms you run on, how big do they typically have to be to run EdgeBox?
You mean the hardware scales?
Correct. Yep.
So currently we are using ARM A35. At least the ARM A35 is okay. And then we also have the ARM chip like A57.
Okay, so usually, go ahead, Tony.
Yeah, quick question. So, and how much memory are typically on those systems?
For example, on the ARM A35, we only have 2 gigabytes.
Okay.
So considering we also have other, although we already have some the neural process unit, we're still facing some memory out of memory conditions sometimes. So we are considering to from one side, we are considering to lower down the EdgeX Foundry, the EdgeX part memory, and the other part we are continuing working on lowering down the AI program where the memory used by the AI part. Yeah.
Okay, and one last follow-up. What are you using typically for operating systems?
Currently, we are based on the Linux Ubuntu 18.04 LTS. we are creating a self-management rootfs from the base Ubuntu 18.04.
Okay, thank you.
No problem.
Only a plug for Canonical. So another question, Dr. Sang and Dan Sang, is you mentioned at one point in your slide, I think it was around the water management use case, you said that you had a latency of about 10 milliseconds. Can you explain that a little bit? How or what is that 10 milliseconds measuring?
This one. This one, the control.
Yeah.
Oh.
So for the
well, actually, we are actually working on some very low control latency part because not only the water affairs are using them. Some like the grid company, they are also wishing to have some control management, especially they want to control some like PLC or other stuffs. So basically, in their scenario, they are expecting we can respond actually less than 1 microsecond, so a millisecond. So we are considering to add some MCU, that is microcontrol unit, or the FPGA parts, or hardware devices to make that part come true.
Got it. So that would be not necessarily part of EdgeBox. That's below EdgeBox then.
Yeah. Because actually, even in the Linux with the real-time patching inside the kernel, it still cannot be satisfy this requirements.
Correct. So when you do engage your AI systems, is there any kind of latency concern there? So if EdgeBox is getting data to an AI system and you're doing some sort of determination or analysis, do you have any latency use case requirements for those kinds of systems?
Well, if we are talking about some surveillance, like for example, there are lots of dangerous areas, so we don't want some people or some vehicles to getting so close. So in that case, actually, 500 millisecond or even 1 second per frame is already enough. So currently, that is not a very big issue.
Very good. We've got a question here from Tony. He says, thanks for your presentation. Have you reported an issue about the problems you've seen with device IDs? And can you provide a bit more information on what it is you're looking for in terms of the device ID uniqueness?
About this device ID, we're still working on it, but we already saw somebody report that issue on GitHub pages in the issue list. I can't remember the issue number, but we can send it to you maybe later. We're still working on it.
That'd be great.
Locate the special places.
Yeah, if there's an existing issue, yeah, if you could just add comments to that, if you could, or send them to us directly, that would be great. Thank you.
Okay, thank you.
I assume this is that anytime you restart the system fresh, you get new device IDs because they're dynamically generated.
Yeah, but
so
sometimes
the ones you were using before.
We observed some strange situations. Just that is sometimes when we register a new device, we get a unique ID, and then we uninstall the EdgeX service and install again. Sometimes we get the original devices. It only has a unique ID, but sometimes it will create a new device.
Yeah, it depends on what. Oh, go ahead, Jim.
No, I was just going to say, when you're looking for unique ID too, are you talking about unique device ID for that EdgeBox instance, or would that be across all of your deployed instances? In other words, how unique does that device ID have to be?
We need the ID to take the camera as an example, because our Edge application need to use the unique ID to collect the images or the videos. So if the ID is changed, the industrial Edge application can't work.
So I think Jim's question was, if you have two instances of EdgeBox, right? Do the device IDs have to be unique across both instances, or only within a single instance of EdgeBox?
I think for currently situation, we only needed be a system on only one instance.
Okay, so it sounds like, Jim, that there may be a bug. You also mentioned you were uninstalling, so I think the best approach here is once you've done a little more investigation, if you could add your comments to that issue, and then we can try and figure out what's going on.
Sure. We're also working on it. Thank you.
Yeah, great.
Guys, Henry asks another question. He says, what tools are you using to remote manage your Edge IoT gateway and other pieces? So for your management solution, we saw the Kubernetes symbol out there. Is that what you're using to manage your applications, or what are you using to manage?
Yeah, currently we have a tool side of selections. One way is from the Kubernetes, but considering the ARM chips are a very small platform on our cases. So we are currently using Docker Swarm or the Docker deployment. So we use those to manage our container and other apps. We also have some very basic components. They're using supervisor D. Yeah, basically that is the how we management, and we limited with the C groups. Yeah, basically that's it.
Fantastic. And with regard to your AI notifications, I noticed you've got that listed there in your roadmap. When you talk about AI integration to EdgeX, what would be your ideal situation there? Are you looking for EdgeX to help manage the models within the system at the edge? Or are you just looking for some sort of AI APIs that get data to the AI system? What are you looking for in terms of integration with AI systems?
Well, for our cases, we are looking for some API stuffs, because currently we already have a kind of system or services that will manage all the AI models, AI model upgraded or rolling back, and providing HTTP RESTful APIs to the users to grabbing those images, videos, and getting back their AI recognized results. And we currently are those kind of RESTful APIs are outside of the EdgeX system. So we're considering to make it into the notification part, so that it will be a more a complete system.
Very good. I think we got time for just about one more question. Anybody have one last question?
Mm-hmm.
Well, I'll ask the last question then, and that is about how many instances of EdgeBox do you have running out there in production? Do you guys have a general sense or general number of how many instances of EdgeBox are out there?
Currently, we already have like 1,000 and some more instances running outside.
Wow, that's great. 1,000 instances, fantastic.
Yeah, and considering we're still we can remote controlling, so we are also providing services and upgrading to those devices if they have enough allocation resources. Yeah.
That's great. Great to hear. Well, again, Dr. Zhang, thanks so much for your time. Dangtang, thanks for your time as well. I know it is very late there. It's coming up on midnight there in China, so we really appreciate you presenting today. Great to hear about how Jiangxing Intelligence is using EdgeX in your development with EdgeBox. I also want to thank Henry Lau from HP for coordinating today's presentation and getting together with Dr. Zhang to get this kind of polished up and ready. I really appreciate it. Thanks, Henry, and thanks as always for everything you're doing in vertical solutions. I also want to thank and give a shout out to Henry, Camilo, Andy, and May, and others in the marketing team for highlighting all of the Adopter Series talks and getting the word out on social media, and then making all this available once the presentations have been accomplished. We're really getting a lot of drag on this in terms of getting a lot of people asking about it, coming to us for more information. And so it has been a real boon to the project. So thanks to you all. And again, thanks to the Jiangxing intelligence team today. With that, I will close out the session. We got the test QA work group coming up in just a few minutes. We'll talk to everybody soon. Thanks everybody for your time.
Thank you, Jim. Thank you for your host.
Thank you, everyone.
Everybody.
Great stuff. Thanks.
Thank you.
Thanks, everyone.